Hello, my name is Eric, and I'm your host in this series of videos on logic. So we've been talking about the paradoxes for the last few videos, and then so today we're going to start a new paradox called the Banach Tarski paradox, and then you can see the name in the caption below. Yeah, but basically, this. I find that this paradox, the Banach Tarski paradox, is a wonderful demonstration of the concept of infinity. Yeah, and then as you know, in logic or in math, there are many ways to deal with infinities, and then one of the ways to deal with infinity is to use a series of countable objects. Yeah. And then there are other ways too, but let's stick with the number of countable objects. But the countable objects themselves are infinite, yeah. So you have an infinite series of countable objects. And remember, the operative word here is countable, yeah. Yes, so a series of objects is infinite, but you can still count them, And then so this is a wonderful demonstration of that countable infinity, yeah. So the paradox goes like this. So you have a, let's say you have a sphere, yeah, and so we're just looking at all the points, on this surface of the sphere, yeah, and then so let's say, there are many ways you can construct a set of all the points, on this the surface of this sphere, yeah? And it turns out that the surface of this sphere can be broken down into an infinite number of points, yeah. But the thing is, this infinite number of points is actually countable, And so therefore, first of all, the first step one is to break the surface of this sphere into countably many number of points, yeah, infinitely many countable number of points on the surface of the sphere, yeah. And then so let's say, for example, this is a set of all the points, yeah, and then we chop up this set of points in two halves, yeah. You have the first half of the points and the second half of the points, and it turns out that the funny thing is you can just take the first half of the points, yeah, and then you can reconstruct the sphere using just the first half of the points, So remember, you have broken down the surface of this sphere into a set of points, and we have chopped up this set of points into the upper half and then the lower half, yeah. And it turns out that we can just use the upper half of this infinite series of points to reconstruct the original sphere, yeah. And so therefore, you can also take the lower half of the infinite number of points to reconstruct another copy of the original sphere, So therefore, voila, you have one sphere. You chop it up into an infinite number of points, yeah. You chop up the set of points into lower half and upper half and the lower half, and you can just use the upper half of the infinite set of points to reconstruct the original sphere, and then the lower half of the points to reconstruct another copy of the original sphere. So therefore, one sphere now can be reconstructed as two exact copies of the original sphere, yeah. And so this is a wonderful demonstration of how you can deal with infinities, yeah. And so in the next video, I'm going to give you we're not going to dive too deep into the math, yeah, but I'm going to give you a very funny way to actually look at, how you can deal with infinity using just a countable number of objects, All right, I'll see you in the next video. Bye.